As climate change continues to grow as one of the world's most significant issues, thermal consequences are directly affecting animal populations globally. Sex determination and hatchling success in green turtles, Colonia mitis, is temperature dependent, therefore increasing temperatures will threaten future populations. Research shows that pivotal incubation temperature, or temperature that produces a 1-to-1 ratio of males to females, is 29.3 degrees Celsius. Any higher produces predominantly females, any lower, predominantly males.
This graph, taken from one article, explained that incubation at lower temperatures, which would produce males, also affects swimming performance. The research explained that these offspring have lower fatigue resistance and slower stroke rates and are therefore less likely to survive in open waters, again affecting male numbers.
A journal article was published in 2009 where loggers recorded sand temperature every hour at 7 common green turtle nesting grounds scattered around the northeast regions of the Great Barrier Reef from November 2006 to January 2009. This map provided by the article shows the locations where the size of the black dots indicates the importance of each nesting ground.
Sand temperature was also taken by loggers using tiny tag temperature thermometers, inserted 50 centimeters into the sand, the approximate level of incubation.
The group also took into consideration beach orientation and shading. Sea surface and air temperature were also recorded. The results found that sand temperature varied among all of the nesting grounds. The results directly correlated with the beach orientation. In some locations that were west or south facing and had some shade did have lower pivotal temperatures. Most grounds, however, being north facing and open, were found to have sand temperatures above pivotal temperatures, therefore producing predominantly females overall. The incorporation of these data sets was combined to configure past, present and future thermal profiles in consideration of the ecological and cultural consequences that may arise if the species is unable to adapt. The researchers formed both a conservative and extreme future models for predicting temperature in accordance to official emissions scenarios.
These emissions scenarios indicated that by 2070 all females might be produced. Alongside this, the hottest sites such as Bramble Key North could see these consequences by only 2030.
The discussion of the paper explains that although future temperature rise seems inevitable and exponential, sea turtles have shown somewhat resilience towards adaptation. They considered the possibility that the species could shift nesting to cooler months for more suitable incubation temperatures, or perhaps relocate nesting sites. A downfall to these possibilities, however, is the time taken for this adaptation response in comparison to the exponential increase in temperature. Hopefully, managers of these areas are able to reduce temperature risks at nesting grounds of northern Great Barrier Reef to allow the species enough time to adapt to these expected consequences of climate change. Thank you.